Well, welcome back to the channel, and in this video I'm going to take a little bit of a closer look at the basic insulation test functionality of the MTR105. Now all three of these instruments can carry out an insulation spot test, which is the default setting that the MTR105 powers up on. The difference between the spot test on this one and both the other two instruments is this temperature compensation method that you have here that you can turn on, and it will adjust the end insulation reading to the temperature that you desire, which at this moment in time you can see hopefully it's at 25 degrees C. I might have to zoom in a bit. Okay, so hopefully you can see 25 degrees C there, and when I press the test button it actually defaults and says the temperature is missing because just above it there is no actual temperature reading. So there are two ways to get the temperature reading into the instrument. Both of them are from the temperature function on the instrument there, and you have a Ttype thermocouple that goes in these two connections at the top, and once you do that you can see the instrument has a reading 24.2 degrees C there. I can put it onto the actual case of the instrument itself, and when I've got the reading I want I hit the save button and it's saved it there, and when I go back to my insulation value you can see now I've got 24.3, there we go, 24.3 degrees C temperature compensation in there. So the other way of doing it back on the temperature setting is to take out the thermocouple. So if you had your own temperature or a thermistor in the winding that you'd taken the temperature from, on the very right hand side here you have a manual entry. So if I hit that I can now set this, and what I'll do if I set it to set it 26.2 so we know it's different, and enter that and you see it's in there now. So now when I go back to there, now you see 26.2 has been entered. So two ways to actually enter the temperature into the actual instrument itself. Now the actual settings for the temperature compensation, as you can see here, it's set at 25 degrees C. If I go around to the settings, and I need to go to the temperature compensation there, I go into that, and here you can see I can set in predominantly 5 degree intervals. I'm not sure about 15.6 degrees C. I presume that's a setting in the standard somewhere, but I'm not aware of it. What we'll do is go to 40 degrees C because that's the IEEE 43 standard, and the other one I have here is in when I go over is the motor class, which you only have A or B in here, so I'm not quite sure if that relates to the NEMA classes. Then there's obviously other classes out there, so I'm not quite sure why the instrument limits to B type. It could be because of the type of insulation. When you get up to class F, which is what I'm used to working on, the actual K factor for the temperature compensation usually has to be calculated unless the manufacturer gives it you. But anyway, that's 40 degrees C class B, so I can go back round to there, and you can see now if I hook in my insulation value, so we'll zoom back out. See, what I'm going to do is position it a bit. What I'm going to do is carry out the test on the winding simulator here. Now, the one thing that I don't quite like about the temperature compensation is that it's only available in the spot test. Zoom in a bit. You can see it's here on the default setting for a spot test. If I go to DAR, you lose it. If I go to time, it's not there. If I go to pi, it's not there. Go to a three-phase test, it's not there. It's only on that default one. So that means for somebody like me, if I do, the majority of my tests will be a DAR test on a motor, 1 minute timing. But if I wanted to do a temperature compensated test and get the DAR ratio, I would actually have to do 2 tests. Whereas if Megger had enabled temperature function for the spot test and the time test and the DAR, then I would be able to do just the 1 test and got all the readings that I wanted anyway. So what I will actually do is time this. I can actually use Keysight for a time test. So I'll do this test for 30 seconds and 1 minute temperature compensated, and then I'll do a DAR test. So the ratio should stay the same, but the insulation values will change. So even though I'm on just a normal spot test, I can still lock the instrument on actually if I wind out. So to get the instrument to lock on, I can hit the test button and hit the lock, and it will lock for me now. And then I'll start a timer off on the Keysight, and I'll use that. So coming up to the 30 seconds. That's 30 seconds. So that's 2.76 megohms. Oh, I know what I've done. Yeah, I don't think I saved it when I set the temperature to 40 because it's saying Class B, 25 degrees C. Okay, let's just go back to settings, temperature. Yeah, what I didn't do. Yeah, okay. I didn't save it properly last time. So this is because, so I'll let you see this feature anyway. Because this is, the winding simulator is capacitive, it picks up, it holds charge for quite some time, and the instrument's picked it up, and you can see there it won't actually let me start a test. So ultra safe in that respect. So what I will do is apply a short for a wee duration, and then we'll be able to repeat the test. Okay, so we're pretty much discharged now. We've only got 1 volt on the simulator, so we can go back to 250 volts. We can enable temperature. Because the, right, so because the instrument's switched off, it's lost the temperature. So we'll go back round to and it should be it. We've still got a 25 there now. Okay, so we'll go again with our 30-second test at 40 degrees temperature setting. Lock him on. So that's 30 seconds there. Okay, so you saw it's 2.78 megohms, which is the default reading that it has. It stayed at that 2.78 megohms because of the charge retained within the winding simulator. Once I've removed that charge by disconnecting one of the leads, it actually reverted then to the temperature compensated measurement, which is 1.39 megohms at 40 degrees C for a Class B motor, which insulation systems have a negative temperature coefficient, so as the temperature rises their insulation value usually goes down, which is what you've seen in the instrument there. Okay, we've got our 30-second reading, so now I'm going to get the 60-second reading, and then we should be able to calculate our DAR value. And what I'll probably do is speed this up a little bit or cut a block out so that we're sat here looking at it for the full 1 minute. Okay, coming up to our 1 minute value, 4.50. You can see it's still holding because it thinks there's a live voltage on there. I'll get rid of that and it gives me the corrected value. Okay, so I'll do another discharge on the winding, and then I will go for an actual DAR test using the DAR function on the instrument, which will be this fellow here. I won't be able to do this temperature compensated, but it should calculate the same ratio from the values I've got from the temperature compensated test. But we shall see in a couple of minutes' time. You can see we're starting off with a discharge winding. Go up to the insulation test. One press of the button takes us through to DAR, and this will give me an automatic test now. And we should get a value very similar to the ratio from the calculated readings of the temperature compensated test, which was 1.62 DAR ratio. 2.50, we were 2.78 previously. Uncorrected reading. Let's see what the 1 minute comes out to. So there you have it. Again, it's not actually completed the test yet because it sees it's got 42 volts on there. So as soon as I pull the lead out, it gives me the values there. So we are 2.50 at 30 seconds, 4.12 at 1 minute, which gives me a DAR ratio of 1.64. In comparison to, if we take the temperature compensated values, was 1.39 at 30 seconds and 2.25 at 60 seconds, which gives me a DAR ratio of 1.62, which is pretty close. Certainly close enough for me. So the ratio is the same irrespective of whether you do a non-temperature compensated test or an actual temperature compensated test. The only issue I have with it is that I have to do multiple tests if I want to do a calculated DAR ratio. Then it looks like the battery pack's just gone flat, doesn't it? Right in the middle of my spiel. Oh well. So yeah, before I was rudely interrupted by the MTR105, it shouldn't matter about the actual method of temperature compensation or no temperature compensation. The ratio stays the same. It's just that if you did want temperature compensated reading, you'd have to do that test, and then if you wanted to record the DAR test, then you actually have to do a second test, which isn't a big issue. It just increases the time test, whereas if they'd made the temperature compensation function available for the DAR ratio as well, then you'd only have to do the one test. Right, so before we go any further, I'll go and find another set of batteries. Okay, so that's a look at the DAR test functionality on the MTR105. The Keysight has pretty much the same function. You can get to it off of the one button, fairly similar to the MTR105. Time test, DAR, and pi there, or just a spot test if you want. So pretty much the same functionality as the MTR105. It just can't do the actual temperature compensated test. You would have to do that manually yourself. The meter hit at the back there, that you can do a spot test on it, and I guess you can do a DAR test on it, but you would have to hold the button in for the full 1 minute, which is rather annoying. So not quite as good a meter as the Keysight, which in turn is not quite as good as the MTR105. So for this specific test, 5 points to the MTR105, 3 to the Keysight, and 1 to the meter hit coil. That's it for this video. Looking at the temperature compensation method on the MTR105. Hope you found it useful. I'll see you again in the next video when I'm going to look at a little bit more functionality on the insulation testing of the MTR105.